This is absolute value functions and inequalities. Objectives for this lesson are going to be graphing absolute value equations with two variables, graphing absolute value inequalities, which is going to involve shading, and you also have vocabulary, which is domain and range, which is from Algebra 1, and right-end behavior, which is a little bit of new stuff as well. Absolute values you have seen before in algebra. These words, domain and range, are going to be talked about a lot in Algebra 2. So these are your standards for Indiana Academic Standards, and we're going to jump right into it. Absolute value function, like I said, you have seen this before in Algebra 1, but we're going to go into more depth with this. First thing you need to know about absolute value function, remember we know the functions very well, y equals mx plus b. That's your equation of your line. It has the slope and has the y-intercept. Absolute value function has certain properties as well. The first thing you need to look at is the a value. What this basically determines is two things. One, if it goes up or down. If it's positive, that means it's going to go up, which means it's going to look like a V. If it's negative, that means it's going to go down, which means it's going to go like an upside down V. And the next thing that kind of determines where the V is going to go is the slope of the right side. So remember, slope is rise over run. That's from the previous lesson. The next thing of importance is the H part of the graph, and if you did the Desmos activity, you kind of see that the shifting, it shifts the graph, the parent function, either right or left. This one, main thing you have to remember is that it shifts the opposite way. So if it's a minus, that means it's going to shift to the right. If it's a plus, it's going to shift to the left. So that is stated here. This part here, the K, shifts it up and down, the parent function, up and down. And so if it's positive, it goes up. If it's negative, it goes down. So that one's not opposite. But in all of this, the thing that you need to make sure you know is this part right here, vertex. This is your starting point. So if you know the vertex, which is your HK point, and that is determined by your H and your K here. If you know this and you apply the right-end behavior and the slope, you'll be able to graph these no problem. Okay, so we're going to jump right into this. So it says state the transformation from the parent function, the vertex, the right-end behavior, and the slope at the right side of each equation. So transformation is basically you're looking at your H and you're looking at your K. This says you're going to do to the right, because remember opposite. So we're going to go right 3. And this one says we're going to go down 8. So down 8. Vertex is your HK. So we know this is H. We know this is K. And remember, you do the opposite. So it's positive 3, comma, negative 8. That's your starting point. So when you graph these, your starting point is going to be at 3, negative 8. Your right-end behavior, you're going to look at your A value. So we know our A value is 2. Since that is positive, that means our right-end behavior is up. It's going to go to positive infinity forever. And the slope of the right side is also associated with this. If you don't remember from Algebra 1 and from the previous lesson, it's the slope has a imaginary 1 underneath it, so it's a rise of 2 over a 1. So that's a run of 1. And we're going to do the exact same thing with the next one. Again, we're going to look at the shifting. So in this case, we do not have any shift to the right or left, so no shift left or right. This one is up by a factor of 9. So all this is going to do is just going to go up 9, the parent function, or the starting one. So the vertex, since there is no shift here, that means there is a 0 for your H. The K is 9, and if you want to put that, that's fine. What some people like to do is they like to rewrite it just because it helps them, negative 5 over 3. absolute value of x plus 0, or x minus 0, does not matter, plus 9, because that shows your h and that shows your k. Okay, so that's your vertex, that's your starting position. Your end behavior, just like in the previous one, you look at your a value, or your slope here, which is negative 5 over 3. Since it is negative, that means it's going to go down. And the slope of the right side we know is negative 5 over 3. And I'm going to even put the other one, which could be 5 over negative 3. Okay, so for this one, if you want to pause the video and try it on your own, you can go ahead and do that. But I'm going to jump to the answers of this. So we're also going to talk about, just for practice sake, remember the Desmos activity. You got wider or thinner. Remember, if you have a fraction that gets closer to 0, that means it's going to be a wider graph. This is shifted to the left because it's the opposite. There is no k, so that means it's not shifted up or down, and that's also why in the vertex there's a 0 and it's negative 7, because that's the opposite, and 0 is your hk. It's up because the slope here is positive, the a is positive, and then your rise over your run is 6 over 7. And then for the next one, again, your 11 and your 9 means it's going to shift left because it's the opposite, and then up by a factor of 9. Remember, this is your h and your k, so it's the opposite of the h, comma your k, which is 9. Your right end behavior is down, and the reason is because your a is negative. Your slope, which is kind of hard to see here, your slope of the right side is negative 3 over 1, or 3 over negative 1. Okay, now we're going to graph this. And so basically we're taking all the stuff that we did before, and now we're going to apply this. The thing that's going to be new is going to be this part right here, which is going to be domain and range. But let's just jump right into this. If this helps you, rewrite the function with your h and k as they are. So for example, absolute value of x, if you want to put a 1 here to help you know that a is 1, plus 0, plus your 6. And the reason I did that and wrote it a little differently is because you can now read off what your vertex is. So my vertex in this case is going to be 0 and 6. And remember, it's the opposite of this one, which there is no opposite of 0, comma this. So that's your h, that's your k. Right end behavior, we're going to look at your a value. So my a value in this case is going to be positive 1. So that means it has to go up because it's positive. That also tells us that my slope is 1 over 1. And the shift. The shift is kind of the important for the parent. The only thing this is doing, because there's only a k here, the shift is up 6. Okay? Before we do domain and range, I'm going to actually graph this. So I told you that the absolute most important thing was the vertex, because that's your starting point. So if you start at 0, 6, that's your starting point, 0, 6 vertex. Okay, so we're going to look at the slope. That's what's going to help us know what our next point is from here. So what we're going to do, from the vertex, we're going to go up 1 to the right 1, because that's rise over run. And the reason it's the slope of the right side is because, well, I'm applying the slope to the right side. So that's your first part of your v. Now, how do you get the second part of your v? Well, what you do is you apply the opposite of the slope, or you mirror it, basically. So what I do is, instead of going up and to the right 1, I go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. And that is it. That gets you your v. So now you have your absolute value. And we know, because of the right end behavior, it's up. The v is pointing up, so we're good. This is the stuff you're going to need to pay attention to, because this is the tricky stuff, is domain and range. Domain is easy. Domain is all set of x values, all x values that are possible in this function. And the way you write it is you have parenthesis, negative infinity. Some people have problems drawing the infinity sign, so I just do two zeros right next to each other that touch, to positive infinity. Positive infinity, and those are parentheses. That's going to be the same throughout every single one of these. Where it gets tricky is the range. So what you have to do in range is you have to look at your k value. So my k value is 6. Since we're going up, that means we're going to start at 6 and we're going to go up to infinity. It's my fancy way of writing infinity. Now, you have to have separated with a comma. The infinity signs are always going to get parentheses. But since we can actually equal 6, infinity we can never equal because we can continue to go on forever and ever. But 6 is going to be an important change because it can actually equal 6. And in notation, in the notation for interval notation, brackets mean that it can actually equal 6. So the range is going to be the one that's going to be the tricky one. Domain's pretty easy. But how this is interpreted is you basically look at the graph. So we're going to look at the graph up here. And what this says, since this is your y-axis, that means all your y values, so basically if I draw a line here, this is not something you have to graph, but that's a y value. You're wanting everything that's above this line. That's why you have everything from 6 to infinity. We don't have anything from the graph down here. So that's why you do not include anything that's below 6. So with that said, range is the one that you have to kind of pay attention to. And all this stuff you're not going to want to graph, but it is going to be important when we actually apply it for the next one. So now this is a graphed with domain and range, and all the shifts, the vertex, and the direction for the right end behavior. Okay, so I'm going to apply exactly what I just did. And again, I'm going to kind of take it through step by step, and I'm going to go a little bit quicker. So I have a -1. I'm rewriting this with all of my h and k values. So we have x minus my 3 plus 0. And again, you can just put plus 0 up here if you wanted to, but I always like to put it here so I know I can read off what the vertex is. So the vertex, remember, is the opposite of this guy, which is h. The opposite of, the positive of this guy, the exact same thing, but that's 0. So your point, your starting point, is going to be 3, 0. And I always like to start that first and graph that first. Right end behavior, we're going to look at, again, the A. Since that is negative, that means you're going down on your graph. So we're going to be going down. That's going to be affecting this part here, and this part here is going to be affecting the range, if you guys remember that. The M, the slope of the right side, you have -1, so it's -1/1, or 1/-1, does not matter. And the shift, we're going to look at, the only thing that's actually shifting is this part right here. We're going to the right 3. Okay, so right 3. And why that's important is because we always, in terms of the shift, we always start at the origin, so that means we're shifting right 3, so there should be a V that occurs right here. So now, we're going to apply the slope in terms of the graphing. So I'm going to go down 1 to the right 1, down 1 to the right 1, and I continue this on forever. Now apply the mirroring part. We go down 1 to the left 1, down 1 to the left. Okay, so now you're going to want to take your ruler. I'm just going to kind of freehand it just because I don't want to waste time kind of changing in between the technology parts. So, but you guys are going to have to do that in a ruler. That's actually not too bad. You guys are going to have to do it with a ruler on your quizzes and tests and for your homeworks as well. It is what it is. So there's my V, and it is an upside down V because the right end behavior is down because the A is negative. Now domain, remember domain, you have your parenthesis set, -infinity, your 2 zeros right next to each other, to positive infinity, your 2 zeros right next to each other. And that's your domain. Now range, remember what I said. First step, you look at your K, where it is. And now since this is going down, that means we're going to -infinity. So negative infinity is where we're going to actually end up. So that means smaller number always goes to the left. We have negative infinity, 2 up to 0, and including 0. And again, the reason for that is if you look at what the graph is doing, the actual graph, if this is your y values, that's y equals 0, your y values is everything down here. Everything down here. You're not including anything up here. So that means all the stuff that's from negative infinity, which is way down here, up to 0, which is right at this point, are included. Nothing is included here. So that basically is notational interval notation that kind of dictates what the graph is doing. So again, you're not going to be drawing any of those lines or the shading part, not for now at least, because it's not an inequality. Okay, so this part here, I kind of took the vertex part away from you, and I'm going to have you guys pause the video and you can try this one on your own. But here is your answer. We have a right end behavior. We have our slope is 1. Again, if you want to put this 1 over 1, just might help a little bit. And again, 1 over 1, just so you know, rise over run, and you're not just doing a rise of 1. The shifting, remember, you have the opposite of this, comma this. Notice that I took away the vertex. If you want to still put the vertex because that's your start point, that's completely fine. I'll put it here. It's -4, comma, -3. So that's your vertex part. And that's going to also be your starting point, so that's your vertex right here. The shifting, left 4 because it's the opposite, down 3. Remember, our domain is negative infinity to infinity, and your right end behavior tells us that it's going up, which means, again, we're looking at the y value, and since it's going up, we're going to start at -3 for the y, and we're going to go up, which means we're going to infinity. That's why it's -3 to positive infinity. And remember, the infinities never have a bracket. They have a parentheses. -3 has a bracket because it can actually equal -3. Okay? And just to kind of show you here, this is your shifting. If this is your parent function, you're basically going to the left of 4, down 3, and then applying the slope formula to this. So, like I said, there's multiple different ways of doing it. However makes sense to you, it's up to you. Okay, here's the next one, and I'm just going to kind of pose the answer, and if you have questions on it, you need to ask me. So here is the answer. Notice the interval notation. Since we're going down, A is negative, so that means we're going down. We start at the 2 because that's your vertex, and then go down from there, which means negative infinity to positive 2 is your range. But again, domain always is negative infinity to infinity. Okay, so the next step to this is applying inequalities. So in Algebra 1, you had this simple rule set, so that if you had a greater than or less than, remember this is greater than, this is less than, that would be a dotted line. If you had an inequality that had the lines underneath it, that means it's a solid line because it's greater than or equal to, less than or equal to. So that's a rule set that you need to make sure because it tells you if it's a dotted line or a solid line. The way I like to remember it is if it has less in the inequality, it's going to be less in terms of drawing, so it's going to be dotted. If it has more, that means it's going to be solid. It's going to include the more ink, I guess you could say. Okay, so shading. Just like in Algebra 1, if you're greater than or equal to, you shade above. Greater than is above. So greater than above, less than is below. So less than is below. So I remember GALB. Greater than above, less than below. I don't know what a GALB is, but if you can find it in the dictionary, let me know. Okay, so we're going to go through this exactly like we did before. Notice that I don't have any of the vertex, the right end behavior, or anything like that because I'm expecting you to know what it is. But I'm going to go through it. So first thing I want to do is find the vertex. So my vertex in this case is the H and the K. Remember, it's the opposite, which would be +1, comma. what your k is, -2. That is your starting point. Over 1, down 2. So to the right 1, down 2. Now I have my slope, or I can also say my right-hand behavior, since my a is positive. It's 1/2, so that means right-hand behavior is going to go up. So that means this is going to look like a V. Third thing, you want to make sure that you have your slope of your right side. So your slope is 1/2. That means from here you're going to go up 1 to the right 2 and continue this on. Now, with this, what you're going to do is make sure, because again, the inequality in this case is a greater than, which means it's going to be a dotted line. So that's going to be dotted. So when you're doing the slope and connecting the points for the slope, that means the line is going to be dotted. Okay, so there's my dotted line. Beautiful. And then you mirror the, or reverse the slope, so instead of going up 1 to the right 2, you go up 1 to the left 2, and continue that on for the entire graph. Okay, beautiful. So now we're looking at, remember back here, if you're shading, we're looking at greater than. So that means we're going to shade above the vertex. So we're looking at the vertex. So if we know this part here is your vertex, you're going to shade above that. Well, above is this way, if you know what above is. So that means everything that's going to be in here is going to be shaded. That's your inequality. That basically means that you can pick any value in this region and it will hold true for this inequality. If you picked a point like out here, like if you picked -4, -8, this would not be true if you plug this into the inequality. All the points that are in this region will actually be true if you plug it into the inequality. You don't believe me? Actually physically try to plug in -4, -8, -4 for your x, -8 for your y, and you will get a non-true statement. Okay, so let's do the next one. The exact same thing holds true. I'm going to go through this a little bit quicker. So again, I like to start off with the vertex. So we have my h, which is 5, my k, which is -8, and I start off with 5, -8, which is way down here. From here, I look at my right-hand behavior. My a is 3, so right-hand behavior means it's going to be positive, which means it's going to go up. Your slope is 3/1, so I'm going to do up 3/1 and apply the slope, up 3/1. And then to get to the next point, you want to do up 3 to the left 1, all the way through. Now, because of this inequality right here, that is less than or equal to, which means it's going to be a solid line. So there's my solid line. Solid V, because the right-hand behavior goes up because it's positive. So now we're going to look at what the inequality is. So since the inequality is less than or equal to, remember less than or equal to is below the vertex. If you look at your notes, below. So I'm going to look at everything that's below the vertex, which is down here, which means it's everything that is below that vertex. So it's basically outside of the V part. And again, if you want to prove to yourself something that is not true, if you tested this point in that inequality and plugged in the point 5, 5 into this function, you would get a false statement. That's part of checks that you guys did in Algebra 1. You don't have to do that though. Okay, here's another practice one if you want to pause the video and try this one on your own. I'm going to pose the answer, and if you have any more questions, you need to ask me. So here is your answer. We have the right-hand behavior goes down. The slope is -4. And if you want to put -4/1, just to kind of help you make sure that you remember going to the down 4 and then to the right 1. The shift is up 5. You have a dotted line because the inequality here is dotted, and you're shading inside because of the less than. So less than means you're shading below the vertex, below V. So below would be, draw an arrow down, and that means everything that's in there. Okay, so now what we're going to do is we're going to kind of go backwards and figure out what the equation is of each of the graphs. And this is why it's important to have a good understanding as to what each part of this graph is, because you're going to want to know this point right here is your vertex. So if you know what your vertex is, that goes -5, 6, so that's at the point -5, 6. You plug it into the equation for an absolute value. So remember, the equation for the absolute value is A times the absolute value of x minus h plus k. So all I'm going to do is I'm going to plug in what I know so far. I know that my h and my k are here. So I'm going to plug in my h and k into this formula. I don't know what a is yet, but I can figure it out pretty easily. So we have x, and it's, remember, the opposite. So since we have a -5, it's minus a -5, which means positive. That's why you have the opposite. Plus the next point, which is 6. And again, if you want to put it as h and k, that's fine as well if that helps you. Now the thing we need to fix or figure out is the a. That's the slope of the right side. So remember the slope of the right side. I'm trying to find rise over run of the right side. So I know I have another point from the vertex here. So I know I go down 1 and I go to the right 3. So rise over run means it's down 1 to the right 3, and there is my finished equation. Now if you want to clean this up a little bit, -1 over 3 or 1 over -3, absolute value of x plus 5 plus 6, that's fine as well. I'll accept either or. Okay, same deal here. What do you do? Find the vertex. So we know the vertex here is 0, -7. That's your h and that's your k. So plug it into the formula. You've got y equals absolute value of a, x minus h plus k. So in this case, I know y is equal to, I'm going to leave a separate for a second. We do not have an h, so I can put -0 or +0 or nothing at all. That's fine. I'll show you a couple different ways of writing it. So plus our -7, and then we figure out the slope of the right side of the graph. So figuring out the slope of the right side, you go a rise of 1, 2, 3 to the right 1. So this looks like it has a +3 and a +1. So rise of 3 over 1. That's one way of putting it, and I would accept that as an answer, because that kind of shows me the intricate details. If you wanted to clean it up a little bit, it could be y equals 3, absolute value of x minus 7, and that would be acceptable as well. Both are going to be acceptable for me, because the top one here, even though it's not fully simplified because you have the plus and negative and you have the 3 over 1, it shows me the details of the absolute value function. Okay, so this one I want you to try on your own. You can pause the video and see if you can do it on your own, but I'm going to go through it, and here is your answer. Again, you can go through the right-hand behavior, the slope, -5 over 1, the shifting, 3, 5. I always start with the vertex, which is +3, 5, and put the opposites in here and the positive here, and then you're basically done. So again, if you're one of those ones that likes to do the parent shift, remember you're shifting from this, you're going to the right 3, up 5. That's where this right 3, up 5 comes into play from the shifting, but it's up to you.